Newton's second law predicts the motion of an object given the forces acting upon it. In this lab, I took a video of a basketball being rolled and then analyzed the video in Tracker in order to create a position versus time graph showing the ball's movement. I then used Python to create a model of the same scenario. This is the graph that I created showing the position versus time data from the computational model and from the video that I took. The blue line represents the position of the ball created in the computational model. The orange line is the observed position data of the basketball being rolled. As you can see, the predicted position data is much more linear than the observed position data because the basketball slowed down slightly after being rolled. In the computational model, the net force on the ball is 0, when in reality there are other forces such as friction acting on the ball and slowing it down. Initial position and initial velocity used to create a model of a ball rolling were taken from the data collected using Tracker. The initial position was negative 0.0247 meters in the negative x direction, and the initial velocity was 0.899 meters per second, which I calculated using the first two data points on the position versus time graph. I measured the diameter of the basketball, which was 0.275 meters, and the mass was 0.48 kilograms. When I analyzed my video in Tracker, I chose to orient the x-axis so that the ball was moving along it towards the right side of the screen, and the y-axis was pointing up. If I were to flip the axes and have the ball moving along the y-axis, then the position versus time graph would have to have the y values instead of the x values from Tracker, and the x values could be ignored. Since the ball was being rolled on a flat surface, the y values stayed fairly constant and did not affect the position versus time graph, so I ignored them when collecting data from Tracker to graph. Tracker automatically graphs the x values versus time when creating a position versus time graph. So if I switched the axes, then I would have to graph y versus time since the ball was moving horizontally. This is what the graph looks like when you flip the axes so that the position versus time graph is graphing the vertical movement of the ball instead of the horizontal movement of the ball. If you flip the axes so that the ball is rolling along the negative x-axis instead of the positive x-axis, the slope of the graph will be the opposite. I don't believe that it is possible to say how many pushes and pulls are added to give zero net force in the case that we observed, because we do not know how many forces or the magnitude of those forces acting on the ball. We only know that they all add up to equal 0. Overall, this lab demonstrated Newton's second law by showing the differences in the movement of an object with zero net force acting upon it and the movement of an object in a real-life situation, where the net force is something other than 0. Although the data was slightly different due to the forces acting on the basketball, the computational model was able to predict the movement of the ball.